All right. Good evening, everybody. So let's get the second day of advanced data structure started. Let's talk about this chart. Yep, that is great. That is just great. And we'll start with the questions we are having. So the first question is, yeah, we are actually starting from the traveling salesperson problem. So what is called traveling salesperson problem and say easy. I just need the minimal for demonstration. Alright. So minimum cost, also known as the Hamiltonian path, assuming the graph is complete. Okay, so what is a complete? Yeah, I know this, but what happens if the graph is not complete? Okay, direct edge. Okay, if there is every pair of vertices have a direct edge between them. That is called a complete graph. Okay, the graph is not complete. Some pairs it does not have a direct edge. Okay, it is no completeness. Okay. So TS canonical assumes you must visit every vertex exactly once you must return to the starting vertex. There must, but brute force TSP called. So yeah, I need to externalize and open. Okay. Treat missing edges as infinity, so the algorithm will naturally avoid them. So we are declaring infinity and then stand for number of vertices if I'm not wrong. So this is a syntematic representation of the graph, and we are having a tracker to see if the vertex is visited or not, and initially setting up the best cost to infinity. Okay, if cost is greater than if count is equal to n, if velocity is not infinity. Okay, this is just graph taking, and so this is a core TSP logic over here. Yep, not the main function. We can take the input and deal with it, but we just need to focus on this thing and this thing, the recursive functions. So you are initially setting the best cost to infinity, and if the cost found is greater than or equal to the best cost, you are going to return it. This is called as pruning, apparently. And if count is equals to n, okay, if there exists a path from the current vertex to the starting vertex, so you are adding the cost to the cost from the current vertex to the zeroth vertex, and if the total is less than, okay, what is total here? Okay, total we declared it here, and total is less than best cost. Okay, so if the found path, the newly found path is better than the previous best path, you are going to update the best path to the current best path. Okay, that's written. And then this is basically the base case, you can say, and this is the edge case or whatever. So okay, next, not visited next, and graph of city of next is not equals to infinity. So if it is not visited, and if there exists a path, you are going to visit it, and you are going to recursively call the function and increment the count, and you are going to update the cost with the by adding the cost of the path. And if the recursive function fails, you will just come back saying that you didn't visit that and try the alternative path. Now things are actually making sense. Okay. So firstly we declare the number of series and this is matrix graph representation, and visited array to track the visits and something best comes to infinity. And actually, before dealing with this problem, I need to deal with another problem. Actually, we had the zero on knapsack problem using the dynamic programming, and I have tried to execute it in the lab, but I got a lot of errors. I don't know why. So let's see if I still can do it or not. And then we will get back to this. So for the dynamic programming using the knapsack problem, you have four things. You will have a number and you will have a weight. So I'm setting up the n to 4 and I'm setting up the weight to 7, let's say. And I am setting up the, so okay, let's do like 5. And since this is going to be a one based array, or you can do something like cost. Yep, value works. So value is going to be an array with one index, so I'm putting the first element as 0, and let's say the value is 2, 3, 4, and 1. Let's do that, and let's have a weight matrix as well. So that is going to start with 0 as well, and let's do weight 2, 5, and 2 and 1 again. So does that make sense? Yes, it makes sense. So these are the constants of the knapsack, and these are the array of the elements, and we need to initiate that. So you need to solve the dp table. Let's do it like 10 dp table, and initially let's do like set it to 0. Okay, I have initiated the dp table, and it calculates everything. So let void knapsack. Let's use that function, or you can do all of this in main by using the function again. Let's do it in void main. Okay, so what are you doing? You need to iterate it. For I is equals to 0 and less than, how many times you should be iterating? And times I plus plus, and this is going to be a nested loop. So for j is equal to 0, j less than double j plus plus. So now you are doing the base case if either the weight of I or value of I. Weight of I is equals to 0 or value of I is equals to 0. We're going to set up the dp of I and j to 0 basically. That is it, and that is not the case. So you need to have best path apparently. Okay, this is iterating here, and so next what are you supposed to do? Okay, forward the logic. God damn it. Because I'm by hearting the code, that is not what you're supposed to do. So weight of yeah, you need to compare the weight with all of the weights, right? With the smaller instance of the subproblem. So this is the smaller instance of the subproblem, and you need to compare it with all of the weights. So if this weight is supposed to fit in the smaller instance, so for that, weight of I is less than or equal to, right, j, and now you are going to use, there are two cases, you can either take it or you can either leave it. So value of I, if you take it, you need to add up the value of I to the previous one. This is the previous one, and you also need to, yeah, this is a weight one, I mean the value one. So this is the value of the previous subproblem instance, and j minus w t of I, because you are subtracting the weight. Let's say if you have the smaller problem has a capacity of 4 and you are taking this 1, you will remain with a capacity of 3. So that is 4 minus 1. That's what's happening here. And you are going to write leave as the previous one. It is just going to the previous one, I minus 1 times j. That's it, right? The weight wouldn't get updated. And you are updating the dp table. Right. Wow. Suddenly the logic kicked in, I don't know. So you are going to take whatever value has the most profit. If take, okay, messed with the syntax. If take is greater than leave, you are going to take, or else you are going to leave it. That is it. And if the size is going to be bigger, you are just, I mean, yeah, no, you will get your dp table ready, and you need to print it. Maximum profit is percentile dp of nw, right? This is, I really presume I have written that in the exam, but it did not get executed. I mean, I did not get any errors, but it gave the answer as 0 for some reason. And I made something, and yep, this, I got the same problem. I don't know why. Yeah. By the way, I tried solving this. Where did I go wrong? It seems like I can take anything in problem and update the data. Alright, I don't know what's wrong. Okay, 3 common mistakes. Oh yeah. Okay, I actually tried updating it to 1 as well, but things didn't change then as well. See, I tried doing that, so that is not the only problem. DPRA mismatch. Okay, but then access DP57 exists, but DP loops zero waste. Okay, I have tried doing this as well. Which one? Less than or equal to W. Okay, I didn't do that. I didn't do that. I didn't do that. But still, I did not change. The DP table seems to be the problem. Um, what? Best case. Okay, no items. Okay. Is the same thing, right? N is equals to 4. Now will it change anything? Okay, maybe that is just a buffer here. Nope, it did not change. N is equal to 4, W is equal to 7, so that is a value, and this is that. And initialize the DP table into K is equal to 1 less than N, I plus plus. Okay, let's do this. Value it to. Wow. Wow. Wow, just wow. Okay. Wow, just wow. Yeah, let it be. So the problem is I have just learned that you are supposed to use a for loop, but I didn't know how to use the for loops properly because I did not learn the DP properly. But still, uh, oh, sorry, man. All right. Hey. Sorry, I didn't see the chat yet. I'll answer this. So I'm coding in C currently because our ADS is in C. And yeah, I mind you, man. Yeah, I have Discord. Yeah, I have some friends. Um, Not so sure that they are seriously interested in coding. Yeah, I'm in college. I am CS. I'm from Andhra Pradesh, by the way. So, how about you? Do you want my Discord? I will drop it in. I didn't remember my ID. Uh, yeah, I'm coding C, man. So C coding is happening here, and I don't know. Yeah, that is just. Yeah, Shankar6640, that's my Discord ID. Long time since I used it. So glad to find a friend. Right. I just wanted to use English. నేనెవరా నేను ఇంజనీరింగ్ స్టూడెంట్ బ్రో సెకండ్ ఇయర్ చదివే ఇంజనీరింగ్ స్టూడెంట్ అంతే నథింగ్ మచ్ ఎనీవేస్ లెట్స్ కంటిన్యూ విత్ దిస్ yep so all it took was to it made the whole drama over there so let's try to understand this one the traveling salesperson problem. Right, I will look at chat after some time because if I keep looking at I get distracted. Maybe one last time. Maybe just check bro code. Yeah man. So So bro code works, but we got an exam tomorrow, like not tomorrow, 2 days after. Face cam agipinda. Nah man. Oh gosh. So should I don't know. I guess it's glitching. I will should I restart the live? Come on, dude. Yeah, I hope things are good now. Yep, the it is working. The face cam's working, and thanks for informing. మా కాలేజేనా బ్రో నువ్వు గెరీన్ ఎఫ్ఎఫ్? Leave it, man. Don't quarrel over there. All right, let's continue. So, what's happening here? So you declare adjacency matrix and number of cities, okay, and set the best goes to infinity. And the TSP problem is you are supposed to travel to a city and you need to track a count of the city, and you need to look at the total cost until now. So it takes three parameters, okay? It takes the city, it takes the count, and it takes the cost. Yeah, obviously you need to keep a track of the city and track of the count and track of the cost. Let's see if there is any. Isn't there any easier way to code the TSP? Yeah, there is much easier way. Okay, minimum code, the simple shortest TSP. Right, swap, permute. Nice. Okay, you don't manually manage visited, you don't do recursive branching for next city, you don't manually track. Generate all city orders, complete cost for minimum, keep the minimum. Okay. Nice. Works for not complete graphs too. Okay. Yep, this works for not complete graphs too. And Hamiltonian path, alright. Okay, getting even simpler, and brute force. So it should not be that hard because since this is for demonstration, we don't care about the time complexity, and it is smaller inputs anyways. Right, it is smaller inputs as well, and print the path too. So it's been 30 minutes since I have started live. Alright, tiny code zero optimization, direct brute force, beginner friendly logic. Okay. Okay. So you're taking zero. Okay, zero for no age. That makes sense. This is example output. No swap, no function separating, but it won't print the path cleanly. No, we will read this one. So you take the number of cities, you take the graph, you take the best cost, you set the best path to store it and to print it later, and you are swapping things using a pointer logic. Yep. copy path. Okay, you are just copying two arrays basically, and permute to the array L and R. Okay, so what are these L and R indicating? They must return to start. Nice, man. Where is this function called, dude? What the heck is this? Oh, where is the function called? Okay, permute setting 1 to n minus 1. Keep 0 fixedness. Start. Ultra 20 line version also have. Yep. Looking at shouldn't right. Solution is intentionally extremely simple. Okay. The smallest possible readable TSP. Yeah, I don't need any more versions. I just need to have a look at this. So, the permutations. Right. If this basically means if there is no edge, you are returning it. Okay. Um, yes, నీకు బాగా తెలిసినవన్నీ. ఓకే. ఇది ద కీబోర్డ్ ఈజ్ వెరీ నియర్ బ్రో. కీబోర్డ్ ల్యాప్టాప్ ఆ దగ్గర ఉంది. దట్స్ వై ఐ నో రిప్లై చూసిన తర్వాత సౌండ్ ఏంటి ఎంత దూరంగా వస్తుంది అనుకున్నా, బట్ కెనాట్ డూ ఎనీథింగ్. ల్యాప్టాప్ కీబోర్డ్ కంటే ఇదే కన్వీనియంట్గా ఉంది. దట్స్ వై. Okay, I don't want to mess up with recursion right now. Yeah, this code seems better. So let's do the permutation of code itself. So you take array and what does that indicate? Can you explain the code line to me, please? So the stream's working. I have heard this dialogue. Are you Vinay Verma? I don't know. Or Karthik. Or Yogi. I don't know. One of those people, if I'm not wrong. Okay, the code seems good. Oh, this code seems good, dude. Oh, what? What? What's happening over here? Let's read this. I have understood the declarations, and you are basically taking every possible path and returning the minimum of those things. So, alright. If there is no path, you are returning it. So, if there is no path means okay. There is a lot of ways this thing can go wrong. Global, so okay, number of cities, adjacency matrix. Use 0 means no edge, best current best path shows the best permutation. Okay. So A is array representing the current order of cities, permutation in progress. L is the current index, we will fix the position where we will place a city now and permute the rest. 0 to n minus 1 are already fixed, we need to decide. City starts at F1. Fix the next position, so on all positions. Okay, we have complete permutation 1 for route. Current index we are fixing. This means there are no contents, one content ordering. Which is in the matrix. A of okay, what is G here? G is A is a formal parameter. Yes, A is a formal parameter. And where are you getting that A from? Okay, we're setting up A. Okay, so got it. It starts from. So this contains 0 to n values. I mean 0 to n minus 1 values. The array contains 0 to n minus 1 values, and the what? This L contains starting vertex. So the L can be intermediate node. Alright. Visual go. Algorithm visualizer, I see. Let's see. Background sound effects. Keyboard sound effects, huh? Or నేను చేస్తాను sounds. What the heck? Yep, Hamiltonians, I guess this is what I need right now. Wow, wow. So play. Can you edit this code? Okay, you can edit this code. Code.js. So nope. Build. Visualize your own code here. How to save this one? You're supposed to save it in JavaScript. Wow, that's a great engine. If I'm not wrong. Hamiltonian cycle. Okay, delete file. Click to confirm. Wow. So is it just wow? You can even change the goddamn extension. Oh my god. Oh my god. Oh my god. So can you do the TSP here? Hamiltonian cycles. So a traveling salesperson problem is basically a Hamiltonian cycle, right? So write the code so I can paste it over there and visualize it. Wow, this site seems to be a gold, right? 4 viewers. Wow, 4 people are watching right now. 3. I didn't expect that. Dude, I need it in see. I mean, I really don't expect this thing to work completely, but Python tutor. No, that's not Python tutor. I'm using algorithm visualizer. Right, that's dot C. I no, this one, dude. How to run this? Build language not supported. Okay. Dot Java. Okay. Because Java is only Java and JS are only. Wait. How can you write it? And one of them with the same code logic. It's not Python tutor, dude. Got a line JavaScript on there as well. It's like Python. Right. And so is it Java or JavaScript? Okay, let means JavaScript only. Build. Okay. Play. Nope. Nope. Alright, sorry man. I cannot do this now. Yeah, I do not have time to mess with all of these things. So permutation, all right. T is equals to what is T? Okay. Alright. Am I missing something? From the steepest line, okay. Building. Alright, let's do this, man. Yeah, it might take some time. Option C, make a path. Alright. 20-day path, okay. We do not even have 20 hours. Right. No, but we can squeeze the 20 days into 20 hours, no worries. Alright. 20 days. Okay, 20 hours. So let's apply all the and will put my 100% total. Still got 3 hours, man. No worries. Single day on a list of randoms, okay. Dude. Should I come from here? Okay, in the phase 3 itself, we are dealing with merge and quicksort, so it shouldn't be difficult. God. Ouch. Um, so if you look at all of our 16 problems, the single source shortest path, the pi-connected components, the n queens, everything's a graph algorithm. Yeah, don't give it up. Especially graph algorithm. No, that's not gate. Right. Active activity selection fraction on knapsack job sequencing with deadlines. 0 on knapsack longest subsequence. He's going even further. Graph representation, BFS, DFS. Dijkstra's Bellman Ford Floyd. Ouch. This thing is even more crazier than our thing. So nah man, I don't want to become a number one YouTuber. I don't see anything in that. Moreover, I want to become a number one coder. If that is the thing, wish me for that. So yeah, I need to. Alright. Yeah, why don't I forward the syllabus? I'm just forwarding the important questions over here. So yeah, the consent. Oh, it's been 1 hour. And if I look back at myself and if I see if I achieved anything, I don't know if I did. Yeah. Mm-hmm. I think the poet in me has came out. Basics to intuition to clean silicon, okay, mini magazine. Yeah, the thing is that we are literally starting out from the hardest problem, the traveling salesperson. So let's not do that. Let's not do that. Right. So where is the TSP over here? Yep, the TSP is in the phase 5. And we started from there. And binary tree SRS heapify down or happen certain delete minimum. Right, I have prepared this. So do we have a heap function? No, we don't have a heap function. I mean, in the code that I prepared. So we are taking an array. Let's statically declare it. 10, 4, 4, 25, 34, 65, 7, something. And declare an array. And alright, let's declare n as how many we have? We have 6 here. And let's declare a heap of n plus 1. And what are we doing now? We are copying every element into the heap and we are heapifying it. That's it. You need I for I is equal to 0, I less than n, I plus plus, alright. And you are doing the int size is equal to 0, the size of the heap, to track the size of the heap. Right? So, okay, you should not initialize this in the for loop, obviously, because every time it will put the size as 0. Declare it once at the outset of the for loop and increase the size, and heap of size is equals to array of I. I have inserted it over there with one indexing, and I am storing that value because the current index that we are dealing with in the value index. So we don't know how many iterations it is going to take while value is greater than 1 and heap of value by 2 is less than. If it is less, then you need to shift it out. Is less than, there is no equal to, yeah, you need to swap the things out. Int temp is equals to heap of value by 2. Heap of value by 2 is equals to heap of value, and heap of value is equals to temp. You are swapping them, and what will you end up with? You will end up with a heap that is sorted, that is in the correct order. So now you just need to print it again. For I is equal to 0, I less than n, I plus plus, come on. Printf, okay. That's actually, that's not n, that's less than size. Okay, you did not declare the size. Actually, you need to start printing from 1, right? That is 1 indexed. So I less than n plus 1. What about that? Percentile backslash t heap of I. This should really work. If it doesn't, I don't know what to do. What? Value. Oh, yeah, it's heap of value. What am I even typing? 2565. Nope. That's not a heap. That's not a max heap, right? Is that the case? No, that's not the case as well. What the heck happened? Dude, that is it, right? Am I printing it wrong? No. Where did we go wrong? The loop is stuck. Ah, man. I forgot this. Like for a while loop, you always need a goddamn updation. Don't buy hard code, man. Just learn it. Yeah, actually, I mean, you need to move it up, right? Yes, you need to move it up. Yeah, it is quite right here, just how it always would be for most of the times. So this is max heap, and apparently if you do this should become a min heap. Yep, that became a min heap. No, 4, 10, 7, nice. 34, 65, nice. 25, it became a min heap. It became a min heap, so you have completed heaps. Congratulations. I'll just copy this phase, mate. Alright, so okay, I have copied another, but now I used it out. Let's see if we use it out. Phase 1, min heap, max heap. Okay, and we actually need to include deletion here. So should we try deleting here? Yep, it is super easy. Delete the max. Okay. No. Alright. What the heck? No. No, 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 no. I don't need that code. Brute force rebuild method. This is the method we are using for everything. Okay. 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 Build heap. Let's just code this one out. It will take a heap and it will exercise. Why are you writing the same code here? Oh, you are repeating the same code. No, just call that build. Yeah. Why are you coding after writing the call? Guess ChatGPT was never really trained on this thing because nobody thinks like this. Yep, just write it once and call it. Yes, I wanted this. And print it. Delete it. Heap of I is equal to heap of size minus minus. What is this thing doing? Deleted. Actually, should we get stuck here? We will think about improvising later. We will think about improvising later. Just let's further move on the roadmap. I completed this. I completed this. So quick sort. They take a lot more energy. And we'll improvise on the deletion part later. How about we copy this code and keep it as a reference for future purposes. Right, cool. Okay, I need to charge this thing. It is 9, right? And things are working. Somebody's calling. Okay, alright. I hope my voice is audible once again. So let's continue. Yeah, where are we? We were doing heaps, alright. Yeah, the next one is quick sort. as usual, the minimal version. Okay, partition. Okay. Okay, ChatGPT doesn't really know how to count the lines of code. If this is 25 lines of code, I don't know what to do. This is a sorting logic, I can see that, and this is another sorting logic, I can see that as well. Okay, now we need to spend some time understanding it. So this is recursion, and I can see that as well. So everything here is something we know. Everything here is a concept that we have used already. Swapping, recursion. Right, pick any pivot partition. They are using that pivot recursively apply the same logic to the left and right sides. Okay, so if your array segment has one element or zero elements already sorted, only sort if there are at least two elements, so there is no high. And partition, you are rearranging the array such that all elements of the left of the pivot are less than or equal to the pivot. Okay, it's not sort the left side of the pivot. Okay, you are going to partition it and sort it recursively. And you are going to sort it right side. That's it. Brian, I'll explain the Lomuto partition method, okay? Okay, that is something that is worth researching. Okay, choose the last element of the pivot. Okay, you are choosing 4 as the pivot. IE marks the boundary where the elements less than or equal to the pivot are placed. Initially, boundary is empty. So, okay, increasing I, increasing the boundary of I and putting it over there. Put pivot in the correct position exactly after. Okay, you chose the pivot as 50, putting the logic together. Everything that is less than or equal to 15 pivot moves to index 4. Obviously, you are searching here. And I said quick sort array 03. Right side, nothing. Nothing. Pivot is 8. If you look at this, 5 comma 2 are less than 8 and is greater than 8. So you will have what the heck is this? This will never happen unless you use templates. But still, ChatGPT is helping us. We must show the gratitude. Okay, so low and high. So initially set that as okay. So why am I having difficulty here? I didn't know recursion. Basically, that is like heart of algorithms. Right. I just know iterations. That the basics of iterations. That's where the problem arises. All right. So partition. Okay, we have written one code. Hey, why am I deleting this? Let's use another Word document to save these things. To save our victories. Um, we're having a partition. I'm saying the same thing again. So setting the pivot to high and initially an empty boundary for low. So J, you are iterating through every element, and if it is less than pivot, you will increase the boundary and swap it. And at the end, you are swapping high and high minus 1, right? Okay. Because you need to swap the elements in the boundary and you need to swap the pivot. And you need to return the index. You need to return the index of what? You need to return the index of the partition, the element exactly where the partition is happening. Okay, quick sort. It takes low and high as well. So while if low is less than high, you are going to partition it. You will partition it and you will recursively call it. So this function will go here, this function will go here and here until this thing works out. Wow, now I am kind of able to visualize it. So this is for the left subarray. Eventually, what is P here? P is the partition element. So explain these two lines of code for me and everything else is set out. What the partition return? The partition return index where the pivot finally sits in its correct position. That is true. All elements on the left side of the pivot are less than or equal. All elements at the right side of the pivot are greater than. So the pivot is now sorted forever. It will never move again. Nice, that is a great understanding. So the pivot stays exactly where it is. Okay. So on the left side of the starting index. Sort the left side of the array, starting from low to the index just before the pivot. Wow. Wow. All elements there are independent of the pivot. They form a smaller array problem, okay? Okay, the low is P plus. Wow. 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 That is a great enlightenment. That is a code. No, we went too far up. This one, right? So, partition. Uh, partition, quick sort. You need to look at the main now. Take an array. Take the size. Okay, quick sort is a recursive function. Just call it once. You need to sort that from 0 to n minus 1 and print it. Wow, it is making a lot of sense. So if we look at our flow chart, we are here. Pattern is pattern, backtracking and AB. Merge sort. Then phase 1 will be over. Yeah, I have learned 0 knapsack, no problem. I have studied some n queens as well, no problem. DB. Floyd version, okay. Job sequencing with deadlines, you will learn that. Single shortest path. Day has been over. Where is day has been? Okay, this takes at least 12 hours. So let us take a 2-minute break and after that yeah, let us take a small break and after that we will start with this. I am learning all of this sorting techniques. Let's say this line up one forever. All right. So let's have a mind map of this. So what are we doing? We have two functions. Partition is a function and quick sort is another function. So this is an array. This is a partition high. So obviously you will have array. You will have low. You will have high. You will set the it's high. Okay, these are the parameters. These are the formal parameters, and you will have the pivot set as high. And what will you do? Okay, so initially this will be our low, obviously, and you will set an imaginary place over here, and whenever, so alright, you need to iterate for j is equals to 0, j less than nope, j less than pivot, j plus plus. If the array of j, so what are you doing? You are sorting, you are placing the smaller elements in the left of that. An element that is smaller than the pivot. An element that is greater than the pivot goes right. Okay, what's happening? Yeah, an element that is smaller than the pivot goes left. Okay, that's what I thought. Element smaller than pivot. Seems like I have written a lot of notes. Yeah, a lot of it. I need to, delete a lot of things. Let's delete this. Drivers. Okay, this is the current one, I see. It is not responding. Very good. I just crashed one note. Okay, thank God. Okay, these things are huge. That's why it is taking time. BSA. Let's do this. This is better, right? Yeah. So this is an array, and you will have partition which will take an array and a low, obviously into low, and it will take a high. So set high. No, set high as pivot, or set pivot as high, whatever makes sense. High current lower bound. as low minus 1. This will increase it. So iterate and iterate until the pivot. Oh my god. You found an element smaller. Swap them. Increase the bound. Obviously, increase the bound and swap them. Swap pivot with I plus 1. Exactly right position. Return I plus 1. Value of pivot. So that is the logic of partition. Oh my god. Alright, I'm thinking of doing 4 hours today. So there are two options, man. I can keep the stream as it is and come back in 15 minutes. The stream goes on live, or I can create a new stream. Yeah, I don't want to waste time while setting up live stream. I will end it over here, and I swear I will come in 15 minutes. So bye, because I need to go and eat something. I'll come back after that. We will get this thing done today. All right, bye everybody. We'll meet you soon.